Welcome to a new video in our series, A Beginner's Guide to the C Programming Language. In our last video, we discussed user-defined data types and understood how to declare and initialize structures and unions. We also saw how to access the members of a structure using the dot operator. Today we will discuss pointers. A pointer is a data type that contains an address to data in memory. The primary use of a pointer is to address memory indirectly. It is a very important topic in your understanding of C. Please like, share this video, follow our channel and subscribe for notifications on new videos. In this session, we'll talk about pointers, how to declare and use them, pointer arithmetic, and finally, the different applications of pointers. As mentioned earlier, a pointer stores an address, which is then used to access memory. The ability to reference memory indirectly is very useful when allocating memory dynamically, iterating through an array, or calling a function by reference, as we do in the scanf function. There are three different ways in which memory can be addressed. The first is a direct form of addressing. In the direct form of addressing, a variable is declared statically at compile time and then accessed directly using the variable name. Every time the CPU addresses data in memory, it needs to know where in memory is the data located. As shown here, the CPU first places the starting address of the memory it needs to address and then will perform a 1, 2, 4 or 8 byte transfer instruction to access the value at that address and move it to its internal register. In the direct form of addressing, the compiler allocates memory to a variable when declared. The address of this memory is then used to access the data within that variable. The base index form of addressing is used when array elements need to be addressed. The compiler knows the starting address of the array and then calculates the address of the element of the array required using the calculation shown and then accesses the element at that address. A pointer provides the third form of memory addressing, that is indirect addressing. Here the address is stored in a pointer and this pointer is then used to tell the CPU which memory you are interested in accessing. So the value of the pointer is an address to another area of memory where the data is located. When declaring a pointer, we first declare the pointer type. Note that every pointer contains an address. The pointer type specifies the type of data this pointer points to. This can be any of the basic data types or user-defined data types that we have discussed so far. Following the pointer type in the declaration, you have the asterisk character, which denotes that this variable is a pointer type. This is finally followed by the variable name. So int asterisk I pointer is also stated as int pointer I pointer is a pointer variable called I pointer that contains an address to an integer value. A float pointer fptr is a pointer variable that contains an address to a float value. A struct employee record pointer epointer is a pointer variable called epointer that contains an address to a struct employee record data. Note that irrespective of what type of data a pointer points to, it will always take up 4 bytes of memory. What changes is the size of memory that can be addressed using this pointer. A char pointer takes up 4 bytes of memory and can be used to access 1 byte of data. That is a char value. Similarly, a double pointer also takes up 4 bytes of memory but can be used to access 8 bytes of memory, which is a double value. Now, once a pointer is declared, it must be initialized properly. Uninitialized or wrongly initialized pointers are a common occurrence in C programming. This leads to runtime errors that are difficult to debug and fix. So please be careful when you initialize and perform operations on pointer variables. There are multiple ways in which a pointer variable can be initialized. If you want to initialize a pointer to point to a variable, You can initialize it to the address of that variable using the address of operator. As shown here, the pointer variable iptr is initialized with the address of an integer variable ival. Now using iptr, you can access the value of ival indirectly. As shown in the diagram, if ival is at address starting at 0x2A00 hexadecimal, then the pointer contains this value of the address. Another way of initializing a pointer is by using the array name, in which case it is initialized with the starting address of the array, that is, it points to the first element of the array. Once initialized, a pointer can be used to indirectly address memory. This is done with the indirection operator, the asterisk character. The indirection operator is a unary operator. It operates on an integer pointer variable. It accesses a value pointed to by the pointer. The type of the value depends on the type of the pointer. So an int pointer will access an int value, a char pointer will access a char value, and so on. So if the variable ival contains a value of 1200 and the int pointer iptr is initialized to point to ival, then the indirection of iptr will give you the value of ival, that is 1200. Let's look at a code example and debug the same. We first declare two integer variables iValue and nValue and initialize both of them with integer values. An integer pointer variable pValue is declared and first initialized with the address of iValue. The three printf statements following it display the values of iValue, pValue in hexadecimal, which is the address of iValue, and the integer value pointed to by pValue, which is the same as iValue. The pointer is then reinitialized to point to the integer variable nValue. The printf statements following again display the three values as before. Let's single step and see how it works. As we single step through the code, check the watch window which shows each variable. The pointer is initialized, then the integer variable is addressed directly, followed by an indirect access using the pointer variable. This is the final output of the program. Let us now see different kinds of operations that can be performed on a pointer variable. Unlike int, float, and long data types, you cannot perform all arithmetic operations on a pointer variable. The only operators you can perform are plus, minus, plus plus, and minus operators. Secondly, the result of these operations are different than expected. Let us see how pointer arithmetic works. Given a pointer variable, any of the four operations plus plus, minus minus, plus, and minus will add or subtract a value to the pointer. The value depends on the type of the pointer. So for an int pointer, plus plus and minus minus will increment or decrement a value of 4. For a double pointer, plus plus and minus minus will increment and decrement the value of the pointer by 8. For the char pointer, a plus plus or minus minus operator will increment or decrement the value of the pointer by 1. Thus, the pointer arithmetic will increment a pointer to point to the next value of the same data type in contiguous memory. You will see this in action in our example here. As you can see, the pointer num pointer is initialized to point to the first element of the array num array in the for loop. The body of the loop prints the value pointed to by num pointer and then increments num pointer. As can be seen in the table to the right, the pointer value is incremented to point to the next element of the array. So the for loop displays the value of each element of the array. Let's debug it and see how it works. As we single step through the code, you can see the array and the pointer value. Check the starting address of the array and the value of the pointer when it is initialized. The value of the first element of the array is displayed. Then as we single step, the pointer is incremented to point to the next element of the array. And the loop continues till it reaches the end of the array. Then the loop exits. This is the final output of the program on the console. We have seen how to use pointers to the basic data types of C and arrays. Let's see how to work with pointers to user-defined data types that are pointers to structures and unions. As we can see here, we have declared a user-defined structure type called struct employee record, and then declared a variable of that structure type. We then create a pointer to this structure called emp pointer and initialize it to point to the variable employee. To access the members of the structure using the structure pointer variable, we use the arrow operator. The arrow operator is a binary operator. It takes two operands. On the left side of the arrow operator is the structure pointer variable, and to the right side is a structure member. Just like the dot operator, which directly addresses the value of a member, the arrow operator indirectly accesses the value of a structure member. Pointer arithmetic works as expected in a structure pointer. The increment and decrement operations will increment or decrement the value of the pointer by the size of the structure. In this case, it is 72 bytes. Let us see how this works in practice. In the program, we have declared a structure type, followed by a structure variable and initialized it. The structure variable is then declared and initialized to point to the structure variable. We then display the contents of the structure members indirectly using the pointer to the structure and directly using the dot operator. As you can see, both the displays are the same. Note that when we use the dot operator, we use the structure variable, and when we use the arrow operator, we use the structure pointer. Let us now look at some applications of pointers. We have learned about the scanf function, which is an example of a function called by address or a function called by reference. When you call a function by passing references to auto variables within it, then the visibility of those variables whose reference has been passed are extended to the called function. What it means is that the called function can then modify the contents of the original variable indirectly, which is not possible when you make a function call by value. Here we have shown the function swap, which swaps the values of the two variables passed to it as arguments. As you can see, the function swap is passed the address of the two variables. The function swap swaps the value of the two variables pointed to it by the two pointers passed to it. On return, the values of the two variables, number 1 and number 2, are swapped. Another application of pointers is to pass the starting address of an array to another function. When the address is passed to the function, the array values are now visible to the called function. We can now use this pointer to iterate through the array. This is done by incrementing the pointer to move the pointer to the next element. Let's debug and see how it works. Firstly, we'll have a look at the swap function. As we single step, note the original value of the two variables. The address of the two variables are passed as arguments to the function swap. We then single step as the swap is performed. When we return to the function main, the values of the two variables are swapped. As you can see, we have indirectly made two auto variables in function main visible to the function swap. In the next example, we pass an array to a function to find the average of values stored within it. Note the address of the array after it is created and initialized. Then the address is passed to the function calcAverage. The parameter arrval has the same value as the starting address of the array. Let us add a new variable to the watch window. This variable is the indirection arrval. This shows the value of the current location pointed to by arrval. Also note, I have added one more watch variable using the expression arrval plus 2. Note the value displayed. You will see that the value of arrval plus 2 actually has added 8 to the value of arrval. This is because the addition operation will add two integer sizes to the pointers. Since the size of an int is 4 bytes, plus 2 will add 8 to the value of arrval. We single step through the function as it calculates the sum of the array values within the for loop. The average is then calculated and returned. An important point to note out here is that while the called function knows the starting address of the array, it has no way of knowing how many elements the array has. So this is a form of tight coupling, because the function calcAverage cannot be reused for other arrays having more or less than 4 elements in the array. One way of resolving this issue is by having a terminating value in the array, like say -1. As we will see in the video on strings, strings are an array of characters that are null terminated. This null terminator serves as a terminating value for any operations on the char array. Finally, let's have a brief look at a pointer to a pointer. We have seen how a pointer can be used to indirectly access basic data types like ints, longs, etc., or a derived data type like an array, or a user-defined data type like a structure or union. In addition to these, a pointer can also point to another pointer. To declare a pointer to a pointer, we use the pointer type, which is the data the pointer to a pointer points to, followed by two asterisks. This declares a pointer to a pointer. Just like a pointer, it takes 4 bytes of memory, but unlike a pointer, which can access an int or a long value, a pointer to a pointer can only access a 4-byte pointer value. That is, a pointer to a pointer can only access another address. Here we initialize IP pointer to point to an int pointer I pointer. So the pointer to a pointer IP pointer points to a pointer to an int IPTR. When we use a single indirection, then the pointer IPPTR returns the value of I pointer. So when this operation is on the left hand side of an assignment operator, it will initialize the value of I pointer. When we use a double indirection, then indirection IPPTR will return the value of the integer pointed to by IPTR. So the first indirection returns the pointer, which is IPTR, and the second indirection returns the integer value pointed to by IPTR. Similarly, pointer arithmetic also works exactly as expected. Since it points to a 4-byte value, increment and decrement operators increment the value by 4. This is the end of this video. Pointers is a very important topic to know in C. You will be a much better programmer if you understand the concepts discussed in the video today. Please follow our channel, like and share this video, and click on the bell icon to receive notifications. In the next video, we will discuss strings in C. Remember, strings are not a basic data type in C. Instead, C implements a string as an array of characters that is null terminated. See you in the next video.